Factoring is one way of solving quadratic equations. So in order for us to factor correctly, we need to review factoring as a whole. In lessons 1 through 5, we're going to review factoring. And we're going to start today with lesson 1. What is factoring? Well, factoring is essentially the reverse process of multiplication. So you have your two factors, your two number factors, and when you multiply them together, you get your product. And these don't have to be numbers. They can be variables as well. And then we learned how to do the greatest common factor when you were around in 6th grade. So let's review what a greatest common factor is. A greatest common factor is a factor that is the largest between two numbers. So let's say we have two numbers, a 50 and a 10. These are products. And when we list the factors for each of those numbers, there are some factors that they're gonna have in common. So for example, 5, 2, 10s. We can do something like a prime factorization tree to get these, right? But the largest factor that they have both in common is going to be a 10. So 50 and 10, their greatest common factor is going to be a 10. There are many ways of getting the greatest common factor. Some people prefer to list the factors going from 1 all the way up. Other people prefer to use a prime factorization tree because we know that products are going to be composite numbers for the most part. And so if we can just get their prime numbers and we can write in an equation that will give us the greatest common factor, we can do that. Use whatever method you prefer, and you'll see me using both at any point during these lessons. It's also important to note that while products are composites, there's also some products that are going to be perfect squares. And the perfect squares are actually the product when two numbers are multiplied together that are the same. So for example, 25 is a perfect square because 5 times 5 equals 25. And so that's the same number being the factor twice. And so when something's raised to the power of 2, we call that a square, and so that's why the product is called also a perfect square. These are going to become very important when we start solving quadratic equations because one way of factoring is by factoring the squares. Before we move ahead, what do quadratic equations actually look like? Well, quadratic equations are unique in that they're called univariate equations, meaning there's only one unknown variable. So a quadratic equation, for example, could look like something like this, a squared plus 2a plus 16. So you notice I only have one variable here, the variable a. Also notice that I have more than one thing happening here. So I have actually 3 things happening. I have an a squared, a 2a, and a 16, and they're being added together. So each one of these individual terms, as we call it, is called a monomial. And those of you that speak Spanish, you may, remember that mono means monkey, but that's not what we're talking about here. We're talking about monomial that means one. So each one individual term is called a monomial. But sometimes you will have equations that will have 2 monomials put together, and we just refer to this type of expression as binomial. And then likewise, when you have 3 monomials put together in one expression, they're called a trinomial. So whenever I say monomial, binomial, trinomial, you know what I mean. And a lot of times I will just simply say polynomials, poly meaning many. Now, however many terms are in your expression, they're going to be united by some sort of operation, and most of the time it's going to be adding or subtracting. So when we are thinking about factoring these expressions that have more than one term, so in this example I have 10ab plus 5a. How would I go about factoring a binomial like this? But before we get there, the most important thing you can do is just identifying what type of expression you're dealing with. How many terms are in this expression? So if we look at our first expression here, 10ab plus 5a, that's a binomial. So I have 2 terms. The second expression here has 3 terms. And the last expression also has 3 terms. Once we know how many terms are in each expression, then we can go ahead and talk about factoring it. Because when we factor these expressions, we're going to have to look at each individual term. And we're going to have to also look at all the terms altogether. So we have to factor the greatest common factor first out of all the terms. Now these can be coefficients and or variables. So let's start with the first example here, 10ab plus 5a. I have two numbers in each term. I have a 10 and a 5. So I'm going to try to get the greatest common factor from 10 and 5. In this case, it's going to be a 5. Now, once I'm done getting the greatest common factor for the coefficients, now I have to go and look at both terms, look at their variables. So I have AB on my first term, and I have an A on the second term. So I know that I have a common variable as well. So I'm going to need to pull out that common variable. I pulled out that 5, and when you pull out a 5, then you have to divide each term by a 5. And so in this case, 10 divided by 5 is 2, 5 divided by 5 is 1, and so that's how we're left with the 2 and a 1 now. And now when I pull out the A's, I have to do the same thing. I have to divide each term by an A. So A divided by A is going to be just a 1, and so on. So all I have left on my first term is going to be a B, and then I'm going to have no A's left on my second term. So a factored expression here would be 5A times, and then in parentheses, 2B plus 1. And there's a way you can check your answer if you did this correctly. You can multiply by using the distributive property. 5A times 2B, 5A times 1, and when you're done multiplying, if it gives you the same thing that you started with, then you did it correctly. So let's go ahead and try to tackle these two trinomials. Let's go ahead and try to factor them. Again, we're going to look for greatest common factors, both in coefficients, numbers, and in variables. So I have identified my coefficients here, 3, 9, and 12. And at any point, if you feel comfortable where you want to pause the video and try these on your own, please go ahead and do so. I'm going to continue to work along as you work along with me. So I've identified the greatest common factor between 3, 9, and 12 to be a 3. So I'm going to pull that 3 out. But then I'm also looking at my variables. I'm noticing my G is only in 2 different terms, but my H is present in all 3 terms. So I'm going to pull my H out. So I've factored out a 3H. And now what I'm going to do is divide each term by 3H. So if I divide 3G to the third power H divided by 3H, I'm going to get a G to the power of 3. That's basically how we're going to do each term. Negative 9G squared H divided by 3H is going to leave me with a 3G squared, and so on. And again, we can check our answers by using the distributive property. Factoring polynomial expressions can get increasingly complicated as you start getting into exponents. Let's look at this one. We have 3 coefficients, 6, 9, and 18. I'm going to list all the factors so that I can come up with the greatest common factor between them. Once I do that, I realize that my greatest common factor is going to be a 3. And then I'm going to immediately look at my variables and see if I can find a greatest common factor with my variables. I have x's and I have y's, and I notice that my y is in every single term. And I also notice that I have y to the third, y to the fourth, and y to the fifth. So my greatest common factor here is going to be y to the third power because every term has at least 3 y's. So I'm going to pull out 3y to the third power as my factor. And then I'm going to divide each term by 3 to the y to the third power. And so our new factor expression is here, 3y to the third power, in parentheses the rest.